In this lesson, we're going to talk about the idea of taking two radical expressions and multiplying them together. Now, what's interesting about this is that it's not much different than one of the lessons we've already looked at, which was simplifying radical expressions. Because in here, really, there's only one more step. Perform the multiplication of the two radical expressions and then simplify. But we want to talk about really quick how we do that multiplication. And then we'll go through the process of simplifying. So the first example we have here is 3 times the fourth root of 15m to the third minus 2, or times negative 2 times the fourth root of 54m to the fifth. Now, since I have two radicals multiplied together, the first thing that needs to be true is that both radicals have to have the same root. They both are fourth roots, so I can multiply these together as is. If they weren't, I'd have to do some manipulation first. But what we're going to do is, since these two are multiplied together and all the operations in here are multiplication, I'm first going to take the coefficients out front, the 3 and the negative 2, and multiply those together to get me negative 6. Okay. And then I have the fourth root of, then I'm going to multiply the numbers together underneath the root. That's 15 times 54. 15 times 54 is 810. So that's going to be 810. Then times, now I've got my m's. M to the, well, we know when we multiply two variables together that are the same, we add their exponents together. So 3 plus 5 gives me m to the 8th. So pretty quickly you can multiply the two radical expressions together. Now's the process of simplifying the radical expression to put it in simplest form, or rather to get as much out of the radical as possible. So to do that, we're going to start splitting it up. I've got negative 6, and I'm going to split the fourth root. I'm going to split this up into the fourth root of 810 times the fourth root of m to the 8th. Now I can split up the fourth root of 810 a little bit more. I can split it up into the fourth root of 81 and the fourth root of 10, and then I still have my fourth root of m to the 8th. Now the reason I split it up into 81 and 10 was, well, first off, 81 and 10 multiplies to 810, but also I know that the fourth root of 81 is 3, because 3 times 3 times 3 times 3, so 3 times 3 is 9, times 3 is 27, times 3 is 81. So what I have now here is negative 6 times 3. Now the fourth root of 10 can't be simplified anymore. And then lastly, I have the fourth root of m to the third. My root of 4 goes into the exponent of 8 twice. So I have an m squared come out of that root. And there's no remainder, so there's nothing left under the remainder. But I did cancel out an even root. So that means this m squared has to be put in absolute value sign. So to finish off this simplification, I'm going to do negative 6 times 3 is negative 18. And then absolute value of m squared. And then I always like to put the radical as the last part. So the fourth root of 10. Okay, so there is the product of those two radical expressions above, and then simplified. So again, you can see that there's not a lot of difference here between this and what we looked at with just the simplification of radicals. There's just an extra multiplication step. Now, there are some other types of situations in which we're multiplying radical expressions. So let's go ahead and look at those. The other situation is when we're taking a radical expression and multiplying it or distributing it into a binomial expression. So in this case, we have the square root of 6r times the quantity 2 plus square root of 3r. So as you might imagine, we're going to take the square root of 6r and we're going to distribute it into each term. So doing that, 6r times the square root of 6r times 2 is 2 times the square root of 6r. Now we don't want to multiply this 6 times the 2 because the 6 is under a square root and the 2 is not under the square root. So we can't multiply them together. And then we have plus. Now in this case, both sets are under the square root. So this becomes the square root of, and we multiply the 6 and 3 together, which is 18, and we multiply the r and r together, which becomes r squared. So we performed the distribution and got 2 times the square root of 6r plus the square root of 18r squared. Now, I do not have like radical expressions, meaning the square root of 6r is not the same as the square root of 18r squared, which means I cannot add these two expressions together. Remember, when we multiply, all we need is the same root. In this case, we have square roots, so we can multiply them together. But whenever you're talking about adding or subtracting two radicals together, you not only have to have the same root, you have to have the same stuff under the root, and in this case, we don't. So what we can do is we can just try to simplify each of these as much as possible. This first one is not simplifiable. The square root of 6, I can't break it up into 4 and any other whole number, which would be the only perfect square that could go into 6. So this one is just done. So let's look at this other one right here. Could I break this one up? I think I can break the 18 up into a 9 and a 2. So the square root of 9 and the square root of 2. And then the square root of r squared simply becomes the absolute value of r, because the square root, the 2 goes into the exponent of 2 once, so one multiple of r comes out. But because I'm canceling out an even root, the r has to go in absolute value signs. Now we know that the square root of 9 is 3, so this becomes 3 times the square root of 2 times the absolute value of r. And this I have with my 2 times the square root of 6r. So to write it in the format that I like, I'm going to go 2 times the square root of 6r plus 3 absolute value times the absolute value of r times the square root of 2. So I peeled as much out of the roots as possible, but I still can't add anything together because I don't have like radicals. So this is where I have to leave it. If I cannot combine the terms, I don't. So there's another example of taking a radical and having to distribute it into a binomial expression, where you end up with addition, or in some cases subtraction, between two terms that sometimes you can combine if they have like radicals and sometimes you can't. So one last example that we want to look at is similar, but just adds a little more complexity, because instead of simply multiplying a single term into a binomial, I have two binomial expressions multiplied together. This also requires us to use multiplication, or distribution, I should say, but a little bit more distribution. So if you recall from doing quadratic equations, and foiling, or multiplying two binomial expressions, first have to take this root 2 and multiply it into both terms of the second binomial. So to do that, the square root of 2 times 5 square roots of 2x ends up giving us 5 times the square root of 4x. 5 from the 5 and the 1 in front of the root 2, and then 4x from the 2 times 2x. To give us that 4x. Okay. Now I have my root 2 times 5 root 5, which gives us plus 5 root 10. The 5 out front is multiplied by the 1 out front here, and the 2 times 5 underneath the roots give us that root 10. Now I take my second term, that's the negative root 5x, and multiply it into each term. So negative root 5x times 5 root 2x gives us negative 5 times the square root of 10x squared. 10x squared. The negative 5 comes from the 5 and the negative 1. The 10x squared comes from the 5x and 2x multiplied together. Lastly, we have negative 5x times 5 root 5. So a negative 1 and 5 give me negative 5 again. And 5x times 5 gives me square root of 25x. So I'm done with all my distribution, and there's quite a bit of quite a few terms here. And what we want to figure out is, can we combine any of these terms? So let's go first through the process. Well, none, as is right now, none of them are like radicals, so I can't combine them. But let's simplify and see if any of them are combinable. Okay, so this first term right here, I see the square root of 4. So this is 5 times the square root of 4 times the square root of x. Square root of 4 is just 2, so that's 5 times 2 times the square root of x, which gets us to 10 square root of x. So we're simplified there. Plus, well, 5 root 10. The only way I could split this up would be into 5 times the square root of 5 times the square root of 2. Neither of these, though, are perfect squares, which means it doesn't help me at all, which means the only thing I can do is revert back to the original 5 times the square root of 10. So in that respect, that term is not simplifiable at all. This next term here, we could split it up into 5 root 10 and root x squared. We already saw that root 10 is not simplifiable. However, this root x squared is. So what I'm going to do is I'm going to take that out and I'm going to go negative 5 times the square root of 10 times the absolute value of x. Because the square, or the 2 in the root, goes into the exponent of 2 once with no remainder. So there's one multiple of x that comes out, but because I canceled out an even root, I have to put it in absolute value signs. So we now have this as minus 5 times the absolute value of x times the square root of 10. Lastly, we have this minus 5 times the square root of 25x. So I could split this up into negative 5 times the square root of 25 times the square root of x. Now we see that 25 is already a perfect square, so this just becomes negative 5 times the square root of x, because the square root of 25 is 5. This then becomes negative 25 times the square root of x. So with each of these terms simplified down, right off the bat I see that my first term and my last term both have like radicals. They both have the square root of x. So I can combine those into a single square root of x term, but I have to do the operation of the coefficients in front. So 10 minus 25 gives me negative 15x. So I was able to combine two terms. Now it might be tempting to combine these two terms right here and here because they both have a like term of the square root of 10. The problem is the piece in front of the square root of 10. Here I have a constant, here I have a constant and a variable, which means I cannot combine these two usefully because the 5 and negative 5x are not like terms, even though the root 10 and root 10 are like radicals. So we're going to leave this separate as plus 5 times the square root of 10 minus 5 times the absolute value of x times the square root of 10. Because I can't combine anything else, this is now simplified. So you can see with multiplication, there's the process of performing the multiplication in this last case, the second case we did, and the first case we did. In all cases, we had to first perform the multiplication, and then once that multiplication was done, simplify it, as you can see in each of these examples. After the multiplication was done, we simplified things down as much as we could.